Hi there, this is Ms. Page, and in this lesson, this is actually the second part of a lesson on how to find the surface area of different types of prisms. In the first part of the lesson, in the first video, we did one example and talked about the concept. I'm starting this video by going over the formula that can be used to find the surface area of a prism if we are given the formula or we remember the formula. So formula for a surface area of a prism we're looking at here. Here's its general form, and what we need to realize is that L, remember, is talking about what's called lateral area. Lateral is a word that refers to sides, and the sides in a prism, remember, are the rectangles. Therefore, lateral area, L, is the area of all of the rectangular sides. And we can calculate that more quickly because we would have multiple 3 or more rectangles, and they may be different sizes this way. And here P, remember, is the perimeter of the base. And all of those edge measurements for the perimeter actually represent the widths of each of the rectangular sides. The height of the prism H represents the length of each of the rectangles, and so the product of perimeter and the height of the prism actually calculates all of the areas of the rectangular sides. We also, of course, have to then add in the area of the two bases. And capital B, remember, is base area. So the formula that we use there corresponds to the area formula for whatever shape our base is. So in a rectangular prism, bases are rectangles, so capital B would become length times width. If we have, like in the first example, if we have a triangular prism, then capital B is area of a triangle, which would be 1/2 times base edge times the height of the triangle, and so on. All right, so now we're going to take a look at a second example. So here we're looking at finding the total amount of wrapping paper, what we actually did for the triangular prism in the first example. Here, though, it specifies that we are to find the amount of wrapping paper in square inches, and we're not doing overlap again to keep it simple. But with the square inches, we are looking at making sure our units are in inches first before we do that. And not all of our measurements are in inches. So we're going to have to first take this 1.5 feet and convert it into inches. So the first thing I would do would be look at that 1.5 feet, which has a denominator of 1 if I want to give it that, and then multiply by my conversion ratio, 12 inches for 1 foot. So my feet would then cancel, and 1.5 times 12 would give me 18 inches. So I want to make sure that I use 18 inches for my measurement here, not accidentally go back to the feet measurement. All right, so second thing is, now I've got that taken care of. So I'm going to now find my surface area here. And in finding my surface area, I can use the formula if I can remember it. So S stands for surface area. Lateral area plus 2 times base area. Lateral area is the perimeter of the base times the height, and so on and so forth. So we need to make sure we understand what goes where here. So one of the things that with a rectangular prism we have to do is decide which pair of opposite rectangles we're going to use as the bases. It doesn't matter as long as we keep track of it. We don't change our mind later on. So we can use the top and the bottom rectangles. We can use the front and the back. We can use the left and the right. It's entirely up to us which we want to do. In this particular problem, I am going to use, I think, left and right. So this is going to be my base rectangle. So its measurements are 9 inches and 5 inches. And that means that that is the rectangle I'm finding the perimeter of, and that is the rectangle I'm finding the basic area of. So the perimeter of that rectangle would be 2 9s plus 2 5s. So 2 times 9 inches plus 2 times 5 inches, or 18 plus 10, which would give me 28 inches for that perimeter. So this is 28 inches. Then I multiply that times the height of the prism. And remember that height of a prism very important, is not always up and down. It's by definition the measurement from base to base. So because of my choice to use the left and the right rectangles as my bases, the height becomes the measurement from the left to the right, which makes my height this 18 inches, like so. Then I have +2, and remember, capital B here is base area. So that has to be area of a rectangle since my bases are rectangles, and that would be length times width. So I've got 2, and my length and width of my base choice rectangle are 9 and 5. So I've got 9 inches and 5 inches here. So now I am looking at taking 28 times 18, and notice I'm going to get inches squared, and this is going to give me the 2 times 9 times 5 is also going to give me inches squared, which makes sense. I wanted square inches, and square units is a area unit. All right, so we can use our calculators. Although for this problem, it's all nice whole numbers, so we could do this without a calculator if necessary, but 28 times 18 will give us 504. And then 9 times 5 is 45, and doubling that gives us 90 for this part. So we get 594 square inches. And then we would write our conclusion here. So I'm going to write it over here. So for my conclusion, again, I'm looking at wrapping paper. So total wrapping paper needed. This, remember, did not require any rounding anywhere, so we would just say is 594 square inches, and here I'm going to use the power notation to finish that problem. Now, we could also do this using a net, and so that would basically, I'm not going to do the full problem, but if you used a net, what you'd be looking at is 2 rectangles that are 9 by 5 inches. That would be the left and the right. And it's not a bad idea to label. You'd have 2 rectangles that are 18 by 5. And that would be the front and the back. And then you would have 2 rectangles that are 18 by 9. And that would be the top and the bottom. And so you would take each of these, area 5 times 9 times 2 would give you 90. You'd have 18 times 5, which is 90 times 2, which is 180. You take your 90, your 80, and then whatever 18 times 9 times 2 would be, add those together, and you should also get 594 inches. All right, moving on to our next example. All right, so here we've got a little different context situation. Said Craig wants to stain all surfaces except the bottom of an old trunk. If a can of walnut stain covers 30 square feet, is 1 can enough to complete the project? And explain our reasoning. So here we'd be looking at a comparison of areas. We know that a can of the stain covers 30 square feet. We want to know, is 1 can enough? So we need to know the area of the surfaces to be covered, and is it larger or smaller than 30 square feet, or maybe it's exactly equal, which would be okay also. Now, notice it says except the bottom of the old trunk. So all surfaces except the bottom. So we have a couple of options here. We could modify the surface area formula to find the area, or we could use a net, in which case there would be only 5 rectangles instead of 6, and we would not include the area of the bottom rectangle. Now, if you're going to use a modified formula, then it's best to use the pair of opposite sides that includes the bottom, because then you can simplify it to just one base. So I would use the top and the bottom as my bases if I was going to use a modified formula, and then I would have my lateral area still plus only one base area instead of two. And my lateral area is still perimeter of the base times the height of the prism, and then again plus my base area. And this base would be the top because I'm not going to include the bottom. So that's one way to do it. Another way to do it is just with a net. So again, similar, and you don't have to draw the net perfectly, it's just a way to organize your work. So you would have two rectangles that represent the left and the right, and you'd have one rectangle representing the top. So we have two of these, we have one of these, and then we would have the front and the back, and we would have two of those to complete, and that would give us the 5 sides that we are looking at finding the area of. So another thing again is units. So here we know that the can of stain covers 30 square feet. So a comparison is easiest then if I calculate the area of the trunk, the sides of the trunk, in square feet. And one of my measurements is not in feet, and that's my 18 inches. So I would also have to, before I begin any other calculations, have to convert 18 inches to feet, and that would be 1.5 feet. And so now I would be ready to go ahead and calculate each of the areas. So the left and the right are 1.5 feet by 2 feet, because those are parallel. So I've got a 2 and a 1.5. And then I have two of these. So I have two rectangles that have an area of 2 times 1.5 square feet. So 2 times 1.5 is 3, 3 times 2 is 6. So this gives me 6 square feet for the left and the right. Plus the top, so the top would be 1.5 feet by 4 feet. So area of that rectangle would be the 1.5 times the 4, and that would be 6. So that gives me another 6 square feet. Plus, so now I'd find the areas of the front and the back, and the front and the back would be 4 feet by 2 feet, and I have two of those, so I have 2 times the 4 times 2 feet, which gives me 8 times 2, which is 16 square feet. And then adding each of those together, let's see, 12 plus 16 would be 28 square feet. So that's the area of the sides of the trunk that are going to be stained. And since 28 square feet is smaller than 30 square feet, which is what a can covers, one can is enough. So now we just have to write that conclusion out. So one can is enough to stain the trunk. So that's our conclusion. Now we want to justify that conclusion. So because the area to be stained is 28 square feet, which is less than, so this is our comparison, less than the 30 square feet a can will cover. So comparison of areas is a really good way to justify. Another way would be to do the difference. It's 2 square feet less than what a can covers. So you can also do that kind of a comparison to justify. All right. Here is a practice problem for you. So I would recommend here that you pause the video, try this problem, and then start the video again when you're ready to check your answer. All right, let's take a look at the result here. So hopefully you came up with the amount of wrapping paper needed as 1,440 square inches. And so one of the things, if you didn't come up with that, is to make sure that you set up your Pythagorean theorem right. Notice that here is the right angle, for the right triangle. So going across means that this side is your hypotenuse C. So you have to make sure that you set up that right. So it'd be 10 squared plus 24 squared equals C squared. So that side turns out to be 26 inches. If that is right, but you still didn't have the correct area at the end, here, this is done using the formula. So remember, the triangles are the bases. This is a triangular prism. And so P is area of a triangle, or sorry, perimeter of a triangle, and capital B is area of a triangle. So your perimeter's area adds up the three sides, or the perimeter of the triangle adds up the three sides of the triangle, 10 plus 24 plus 26, multiplies that times the height, which goes from triangle to triangle, which would be this 20 inches. That's the pH part. And then two triangular bases. So we have 1/2, and remember that B and H, so area of a triangle is 1/2 little b, little h for the triangle, and little b and little h for a triangle form the right angle. They're perpendicular to each other. And again, there's that right angle, which means that your 24 and your 10 inches have to be little b and h for that calculation. All right, moving on. Here is another practice problem for you to try. So again, I recommend you pause the video, try this one. Okay, let's take a look at the answer to this practice problem. So here we have, hopefully you came up with the area to be painted as 20.5 or 20.5 square feet. So one of the things that had to be done was you needed it in square feet, so you had to convert the inches into feet. Hopefully you did not round here. That would be inappropriate. So we use our exact measurement after we convert of 2.75 feet. So we wouldn't use this, we'd use the 2.75 feet. And then we're going to paint all surfaces of the trunk this time. So we don't have to modify the formula here. So this kind of breaks it down into pieces. So finds the perimeter of the base. Here, the bottom and the top were used as the two bases, which is what I did with the trunk problem where we excluded the bottom. And so the area of the bottom, or sorry, the perimeter of the bottom would be adding up 2 1s and 2 2.75s as we see here. And then the height of the trunk would then go from top to bottom, so that would be the 2 feet. So we're looking at perimeter of 7.5 times the height of 2 feet, and then 2 bases. Area of a base, remember, would have to be length times width because it's a rectangle base now, and the length and the width would be 1 and 2.75, giving us 2.75 for that area. And that's where our 20.5 square feet comes from. All right, moving on. So here is a little closure for this particular lesson. So especially with using formulas, if we have the formula given to us, or if we remember the formula in general, we also have to know how to interpret it. So one of the important things about the surface area of a prism formula is, what does P represent? What does P represent? And making sure that we interpret that and calculate it correctly. So, got in mind what P represents? About to reveal. Let's take a look. Hopefully you said that P represents the perimeter of a base of the prism. And remember, the base of the prism depends on what kind of prism you are working with. Triangular prisms, it has to be one of the triangles that we do the perimeter of. If we have a rectangular prism, then we have to make a choice which pair of opposite rectangles we're going to use as our bases and make sure that it is one of those rectangles we find the perimeter of for that part of the problem. All right, so that concludes this particular lesson. You guys have a great day.